Hi JD, my name is Lauren Dailey and this is my Quiz 8 video quiz. Okay, so the question reads, the U.S. Post Office will accept a box for shipment only if the sum of height and girth is at most 108 inches. Find the dimensions of the largest acceptable box with square top and bottom. Okay, so I already drew out my representation. I flipped it on its side as if this was the top right here, just for me to better visualize it. So the dimensions are going to be, you have a width here. This is a square, so these two are going to be the same length. And the girth is, draw around this, as if you were going all the way around the box. So we're trying to find the dimensions with the sum of the height and the girth at most being 108 inches. So that would be the girth. Here would be length, width, length, and width. So 2 lengths plus width, well, 2 widths, plus the height of the box, which is also L right here. And this is at most 108 inches. Okay, to simplify that, that's 3 lengths plus 2 widths equals 108. And then, so the volume is normally of a cube or a box is length times width times height, but we are using 2 lengths because it is a box, so it's going to equal length squared times the width. And in order to solve for this, we need to take out one of the variables here and get it by itself. So I'm going to do the width. So 2w equals 108 minus 3l. And so w equals 108 minus 3l divided by 2. And then we are going to plug this back in here. So it is 108 minus 3l divided by 2, which equals 108 divided by 2 is 54 times l squared minus l squared times 3/2 l. So that would be 3/2 l cubed, because you're going to take this squared here and there's an exponent of 1 there, so you add those. And then when we're trying to find the max volume or anything max or min, you need to find the critical numbers, because the critical numbers are where local extrema are located, which is either a max, absolute max, or a local max and a local min. And so since we are trying to find the max, we want to find the local max. So first we need to find the critical numbers, which in order to do that, you take the first derivative of this right here, this equation. So we're going to take the first derivative in respect to length, which, so you bring the 2 down, which is 108, L, 2 minus 1, which is 1, minus, bring the 3 down, 3 times 3/2 is 9/2, L, 3 minus 1 is 2. And then from there, to find the critical number, you need to set the derivative equal to 0. So 0 equals 108L minus 9/2 L squared. In here, you can take out a 9/2 L. So 9/2 L times 24 minus L. Set both of these equal to 0. So 9/2 L equals to 0, and 24 minus L equals to 0. So L equals 0, 0, and 24. But the 0 is not possible because you cannot have a box with a 0 dimension. So 24 is going to be your critical number. So from there, you are going to take the second derivative, because that tells you whether it is, like, so the first derivative tells you if they're, like, where the local extrema are. It doesn't tell you whether it's a max or min. So you have to take the second derivative to determine whether that critical number is an absolute max or an absolute min, or a local max or local min. So to do that, you have to take the second derivative. So I'm going to do that over here. Second derivative of v of L equals, and so that is going to be the second derivative of this equation right here. So the derivative of 108L is 108 minus derivative of negative 9/2 L squared. You bring the 2 down, the 2's cancel, so it's going to be 9L. And then since we did find the critical number to be 24, we are going to plug that into here. So V double prime of 24 equals 108 minus 9 times 24. So that would be 108 minus 9 times 24 is 216. So that's going to be negative 108. And that is the second derivative. Since this number is less than 0, the second derivative, if it's less than 0, it's going to be concave down. So if it was positive, then it would be concave up, but since it is concave down, which is this, you now know that the 24 is a max, because concave down, the point's going to be right there. That's going to be a max value. So we have the max value of L. If we plug it back into this equation up here, so that'd be 3L plus 2W equals 108. Plug in the 24 for L. Oh, not 180, 108. 3 times 24, 24 times 3 is 72. So 72 plus 2W equals 108. Subtract the 72 from both sides, so 2W is going to equal 36. Divide both sides by 2, and W is going to equal 18. So the dimensions of this girth for the max, the max sum of the height and girth is going to be, since there are 2 L's, so it's going to be 24 inches times 24 inches times 18 inches. And that is your final answer. Now this answer means that these dimensions are the largest acceptable to make the box, having the sum of the height and the girth all the way around at most equal to 108 inches. So this is the max that it could be.